objective is to learn the MATLAB program for Huffman coding. To understand the algorithm for Huffman coding, first we need to understand the Huffman coding and how to find the coding efficiency by using Huffman coding. Huffman has suggested a simple method for constructing the code with low redundancy. Let us take one example to find coding efficiency by using Huffman coding techniques. Apply Huffman coding for the following message and find the coding efficiency. 4 messages are given: x1, x2, x3 and x4. Probabilities of these messages are given 1 by 2, 1 by 8, 1 by 4 and 1 by 8. That is, probability of message x1 is 0.5, probability of message x2 is 0.125, probability of message x3 is 0.25 and probability of message x4 is 0.125. Now first step, we have to write all the message in decreasing order of probability. x1 probability is 0.5, message x3 is having the probability of 0.25, x2 message probability is 0.125 and x4 message probability is 0.125. All the messages are in decreasing order of probability. In second step, we have to add last 2 probabilities and then place addition of these 2 probabilities into the next step, that is again in decreasing order of probability. For example, last 2 probabilities are 0.125 and 0.125. Addition of these 2 probabilities is 0.25 and this is placed in the next step in decreasing order of probability. In third step, we have to assign 1 and 0 to the 2 messages x2 and x4. Here 1 is assigned to this x2, 0 is assigned to x4. Then repeat this procedure till we get the addition is equal to 1. For example, in this step we have to add these 2 probabilities. Addition is 0.5, 0.5 is placed here and this 0.5 is shifted here. Last addition 0.5 plus 0.5 is 1. So we need to repeat this procedure till we get addition as 1, and every time we have assigned 1 and 0 to write the number of messages or the number of bits required for representing the particular message. Now these are the messages x1, x3, x2 and x4. The number of bits required for representing this x1 is 0. The number of bits required for representing the message x3 is 10. Number of bits required for x2 is 111 and for x4 it is 110. These are the number of bits required for representing this message. Now the question is how to decide the number of bits required for representing the particular message. For example, for x1 we have written here 0 and number of bits is equal to 1. Now if you see this message x1 with the probability 0.5, we have to follow this line. This is the 0.5, arrow is here and we have assigned 0. Therefore this 0 is required for representing x1. Now for second message x3, the 2 bits are required, that is 1, 0. See the message x3 and follow this line. Probability is 0.25, arrow is given here. Here we have assigned 0. It goes to 0.5 and we have assigned 0. So 0, 1, take it in reverse order, will become 1, 0. The number of bits required for representing x3 is 2. For x2, see the probability 0.125. We have assigned 1 here. Follow this path. 0.25, 1. Then it goes to 0.5, 1. So 1, 1, 1. Take it in reverse order. For x2 representation, 3 bits are required. 1, 1, 1. And j is equal to 3. Similarly for x4, x4 it is 0.125, 0. Follow this path, 1. Then it goes to 0.5 and 1. 0, 1, 1. Take it in reverse order. Becomes 1, 1, 0. Now to find the efficiency is given by h of x by L bar into log of m to the base 2. H of x is the entropy, can be calculated by using this formula, j is equal to 1 to m probability of xj into log base 2 1 by probability of xj. Probabilities are given. These are the probabilities x1, x2, x3, x4. From these probabilities, we can find out the value of h of x. It is 1.75 bits per message. L bar is the average code word length and it is given by this formula. L bar is equal to summation j is equal to 1 to n nj into probability of xj. It becomes 1.75 bits per message. Log of m to the base 2 is equal to 1 because here the value of m is equal to 2 as we are using only 2 bits, that is the zeros and 1 for representing all the messages. Therefore, the value of m is equal to 2. Log of 2 to the base 2 is always equal to 1. Therefore, the efficiency is equal to 100%. This is the Huffman coding technique to find out the efficiency. CLC and clear all. CLC, it clears all the input and output from command window display, giving you a clear screen. Second instruction is clear all. Clear all will clear all the objects in MATLAB. Code underscore length is equal to 0. That is, initially the code length is assumed to be 0. In this step, we have to accept the number of symbols. That is, x is equal to input, enter the number of symbols. For m is equal to 1 to x, symbols m is equal to input, enter the symbol number. First, we have to enter the number of symbols. For example, if we are going to use 4 messages, then enter the number of symbols is equal to 4. Next, enter the symbol number. For example, 4 symbols are there. Enter the symbol number as 1. Next, enter the probability of corresponding symbol. If 4 messages are there, then enter the symbol number, total number of symbols 4 first, then enter the symbol number 1, then enter the probability for symbol 1. Symbol stands for the message. Then h of x is equal to 0, that is, entropy initially is assumed to be 0. Then to calculate the efficiency, our objective is to calculate this efficiency is given by h of x by average length multiplied by 100. So to calculate this h of x is the entropy. The formula to calculate this h of x, in this step we have the calculation of entropy. H of x is equal to h of x plus p of m into minus log p of m by log of 2. We will get the value of this h of x. Next task is to calculate the average length for the particular code. To calculate this average length, we have to use this syntax, that is a dictionary, comma, avglen, that is average length, is equal to Huffman dict, symbols, comma, p. It will create a Huffman dictionary based on the symbols and their probabilities. Then the encoding and decoding of the Huffman code is done by these two codes, that is the H code and the SIG. H code, it encodes the signals. SIG using the Huffman code described by the code dictionary. The SIG stands for the signal, that is the Huffman decode comma dictionary. It decodes the numeric Huffman code vector form using the code. Code underscore length will calculate the average length required for the code and it is given by avglen. Therefore, efficiency is equal to h of x by avglen multiplied by 100 will give the value of efficiency. Then run this program. First, enter the number of symbols. If 4 symbols are there, enter the value as 4, as the total number of messages are 4. Enter the symbol number, that is, enter the first symbol, that is 1. Then enter the probability of first symbol,